Now and recording. All right. So this for those that didn't come to the latest to the previous classes, I've been explaining the process of making a walk cycle, and this is the result of those lessons. Well, the live streams. So I did this like very step by step explaining the theory behind it and all the walk cycle principles and all that stuff. So it's not
And just for
pretty.
the people that want to rewatch it, it's up there in the live stream channels. We posted all the previous lessons as well, so you can just go there to see the replays.
Exactly. You can watch the whole thing in YouTube on my YouTube channel. It's not perfect from this angle. It looks better from the side right now, but it doesn't matter. I mean, it's just for the purpose of more like a teaching and kind of explaining the what's the process behind. And I did this whole thing using frame by frame technique. So just you can see here on the layer is just one different drawing in every frame, right?
Okay.
I didn't use transform keys, so you can see here. So I did this. Well, you'll see on the videos on YouTube is in between in a traditional way, and I worked on the keys first, and then I put the in betweens later on. So I basically these live streams that I've been doing are very oriented into using the traditional animation methods and how and applying that to a modern super modern tool like Quill, right, and virtual reality. So we're gonna continue with that. I'm gonna animate the arms, and for that I wanted to explain some concepts that are very important for this kind of animation where you have a string of different joints, right? In this case, the arm is a bunch of joints together with a flexible part here and another flexible part here, the elbow and the wrist, right? So we're gonna talk about a little bit of that. I brought some images from Richard Williams' animator's survival kit, right? And he has a couple of pages where he talks about the breaking of the joints and successive breaking of the joints. And what he means by that is basically like you have articulation of joints, right? And there's a father joint that basically moves the children joints. And when the father changes direction suddenly, because of the flexibility of that joint, there's a breaking of those that happens in that movement, right? Also, there's a couple of concepts and words that apply to that. So drag is a word that you're gonna hear a lot. Dragging. So the father joint is dragging the children joints, and because of the flexibility and the amount of rotation available in this flexible joint, the children have a tendency to have the opposite direction of rotation, right? I think here is very clear as well. You can see you have these two key poses, one down and one up. This is the first, this is the second, and then in the middle we adding this pose here, where we call that the breakdown in between, or whatever you want to call it. And then in here there's a breaking of the joints, right? So the father joint, the top of the arm is going first, but the bottom of the arm is bending down the opposite direction. It's trying to go back to the previous position, and that principle is consistent if we add more in betweens, right? And then we're gonna see that in a more practical way. So for this example, I would like to animate this with transform tools instead of the frame by frame. The reason why it's gonna be easier to have some sort of a rig and make sure that these children joints are perfectly following the father joint, in this case the arm, right? So I set up a rig here, very simple. So chest, is basically a group that I created that follows the chest, right? More or less. It's not perfect because what I did here is a little bit wobbly, but it's okay. Just for the class, it doesn't have to be perfect. Okay, so that group is following the chest, and the arm group, arm right, it's a group that contains all of these pieces, right? And I'm gonna animate the shoulder in this group. Okay, so that's the shoulder pivot. I'm gonna maybe start some keyframes here for the swinging motion of on the walk cycle, right? So more or less in the middle, I'm gonna get this, and I'm only for now I'm just using one axis. Just oops, I should have hit record. So let's do that again. In the middle, swinging this way. Actually, it's going to be better if I duplicate the first keyframe by not having anything in the middle. At the moment,
So
that's
quick tip there. If you do the if you want to make like a loop, you want the first and last keyframe to be the same. But in order to get to the last frame, you can just create a keyframe anywhere and then drag it, because you already set the loop in the sequence. Yeah, it doesn't go beyond. So that's like an easy
won't
way.
go any further.
Yeah, so that's like an easy way to just set a keyframe really quickly.
Oh yeah, that's cool. I didn't know that.
Yeah.
Yeah, it won't go past the loop point. Yeah, I already set up the loop, so you guys already know how to do all of that. Goro explained it in very in depth in the last session, I believe.
Yeah.
So I'm not going to talk about that. Okay, let's make that arm swing very simple, just for the shoulder motion for now, right? So we have the arm swinging there, and we're going to start applying those principles of breaking the joints. Opa, sorry. So I have different joints here. This is the arm one, so this I'm not going to touch that one. I'm going to animate arm two, which is the elbow. Again, we're going to do keyframe at the beginning and keyframe at the end. Just drag it at the very end. And just following the theories from the book, when the father arm is rotating that way, let's just change the camera here. That'll be easier. So there's a motion of the father parent moving in that direction, right? The elbow is going to rotate in the opposite direction. Oh, that's a mistake that I did on the rig. So let me fix that quickly. So we need to create another group. Let's just put that in there, and let's just put that in there. And actually, we're gonna need another group here.
So while he's doing that, I do that also too. Like whenever I animate something with transform keyframes, I make sure I covered it last week as well. But I usually use groups to animate, because the advantage is that you can reuse the group animation for any paint layer after that as well. So the cool thing is then you can mirror it and adjust animations without actually touching the paint layer. Because if you have transform keyframes on a paint layer, you can't apply those onto other paint layers. But if you have it on a group, you can always duplicate the group and move the group around and put other stuff inside the group, maintaining the animation. So whenever you use transform keyframes, unless you're like absolutely sure that you only need the animation for a paint layer, I would always animate a group instead of a paint layer. And the good thing is, regardless how many nested layers you have, nested groups you have, it will not affect draw calls. So the draw calls will only get affected by how many layers you have, but not groups. Groups and sequences are not part of that, so you can have like tons of them, and it's fine. And what Daniel just did is he created a rig where he's going to animate the folders instead of the paint layers.
Yeah, the folders are basically the joints. Okay, and if this joint is inside this folder, means that it's gonna always follow this joint. So it's very much like a parenting rig in Maya or any other software, right? So going back to the animation, we're just gonna counteract the motion of the father joint by rotating it backwards. So it's the opposite motion from the children, and you could also call this a drag. And why is a drag? Because it's dragging the father joint is dragging the children joint, and the children joint have a tendency to look where to orient themselves where the how do I explain this without I need somewhere to I need like a layer just to draw. It's hard to do this. Well, anyway, this is where the hand used to be, right? So the elbow is gonna rotate backwards because the hand wants to be on the previous wall space point that it used to be before. So that's called a drag. It's dragging, right? So all those principles apply, and then here, let's just get rid of that. Oh, maybe not. Let's just continue. Anyway, so now the motion of rotation on the father stops and changes direction to another direction, right? It's rotating the other way now. If I go here and I just want to draw these arrows. Okay, it's going the other way now. So what's gonna happen on the elbow is we're gonna start rotating the opposite way, that way. Okay, and what's happening here as well when I did this is a little bit of a delay as well on the motion. So the motion of the father stops here, the father joint, and then changes direction now. But the children, the motion of the children stops a little bit later, so it's offset, and that's why we also call this overlapping action, right? Because one action is overlapping the other. So we got that dragging motion there, and eventually the elbow goes back to the same pose as we had before, but we want to keep that drag happening. So I'm gonna add one more keyframe here to make that feeling of dragging here. And the amount of rotation is going to depend on the flexibility of the joints, right? Opa. I think it's not doing exactly what I want, but it's okay. Yeah, depending on how flexible this joint is, you're gonna add more or less of this bending backwards the other on the opposite direction as well, right? So if we have an elbow that, imagine this guy has the muscles of the arms really tense, so we wouldn't do that as much. We would just dial it down a little bit, but it has to be present, you know. So imagine this is the beginning position, and this is the dragging. So I dial it down on it, but it's still there, you know.
You might want to undo this because it won't loop properly now.
I know.
Okay.
Don't worry. So yeah, that's very important to know how much to dial it down depending on the character that you're animating or the material of the thing that you are animating, right? That's very important. The material physical properties of that thing is going to affect how much um, that drags. So let's go back to what I had before. This, I think it was better. I think it had enough. Yeah. Okay, so the same thing applies for the wrists, right? So the children of the children is going to follow the immediate father, right? So this is a grandchild right now. So we're gonna do also the same. So I make sure it loops. But yeah, like I imagine the wrist is a little bit more flexible than the elbow, and it has more range of motion, more range of rotation. So I'm gonna be a little bit more flexible with the wrist. And you're gonna see here, I'm gonna just look for the right moment where there's a big change in the direction. In this case, what am I doing? Oh, I think it's creating keyframes here without me wanting to. Sometimes I just want to draw something. Oh. Oh, because it changes to that. Okay. So there's a big change here on the father, on the arm. So the wrist is going to compensate by rotating the opposite direction and always trying to find where it was on the past, on the previous frames. So it's going to try to point itself to that previous position. I don't know if that makes any sense. See what I mean? The tip of the fingers, they try to be where they used to be before, and that gives you that impression of a dragging motion, right?
You have auto key off.
Yeah. Let's put it back on. Yeah, the onion skinning for the transform keys works a little bit different. It shows you a box instead of shows you the.
And I think it's because it's considering the bounding box of the object.
Yeah,
maybe.
It's not the same as when you do the. I prefer the onion skinning on the frame by frame version, but
yeah.
I mean the box is good sometimes because it allows you to do very tiny little small movements and you can see how much you moved it, but that's okay. Let's keep without the bounding box. But you see the principles here. Like I try to keep that very flexible, and I'm breaking the joints like the Richard Williams says. And here we're gonna have a change of direction, okay? A big one actually. Boom. And that's where I put my next keyframe. Okay? And you can see how we're starting to see a successive breaking of joints. So first is the elbow breaking, and then after the wrist is breaking. So they're overlapping each other. They don't happen at the same time. The breaking of the elbow happens first, and then this one happens later. So for me, all of that stuff is really like in my brain. I don't even think about. So for me, doing this class is really hard because I have to put towards something that I do. So I do without even thinking. So this is something that trained animators do, and you don't even put a thought to it because it's supposed to be in your brain. It's supposed to be so natural for you, and once you learn it and you start practicing with it, it'll become natural. So that's the dragging motion on the arm. It's very smooth at the moment. It's very
Can
even.
you zoom out a little bit?
Can
you move on? Yeah, exactly. Nice.
So at the moment, the timing is not right now. The timing is wrong. It's all very even, and it's kind of floating away. It's not good. So I'm gonna change that a little bit, but I wanted you to understand the whole principle of dragging, right? And this it has different names: dragging, breaking of the joints, follow through, overlap, whatever you wanna. All those names are are referring to the same principles, right? So
you wanna save real quick?
oh yeah. So the timing is going to be a little bit tricky to do, but basically to fix the timing, I talked about the timing on the first class, but what I'm going to do is just making the especially the elbow and the wrist, I'm going to make that a little bit less even, so they don't float around so much. So so the transitions are going to be a little faster. So let me get this elbow favoring the next pose. So we have a little bit faster change on the elbow there. And and that's going to be a little faster here, changing directions. And I'm going to do another keyframe that favors favors the last keyframe. So now we have a little bit more of contrast, and the timing is not so even. And for the wrist, the same thing. Just gonna actually, it's not too bad right now. Maybe it should be like that now. So the braking here is gonna be faster. Over there. Well, it's not perfect. Okay, maybe here we have a little bit of drag over there from the previous movement. And here we're gonna have a faster break here. It's a little bit more flexible, maybe.
Daniel, where in a walk cycle do you say you spend the most time, or it's the most important to finesse, like arms or legs? Or is it about the same?
Everything is important, I guess.
Mm-hmm.
Okay. Obviously, I would definitely keep working on that until it's a bit better. But I'm gonna move on to something else before I get too obsessed with this. But you get the idea. It's a little too floppy right now.
Got some sad.
It's got this. Yeah, I added. It's a little too flexible, that wrist. Right?
It's like John Travolta.
Exactly. Yeah, it's kind of it's kind of doing the moonwalk a little bit. But we could also have the same wrist motion a little bit less flexible. Let's do a new version of this. I'm using different axes as well because the wrist has more of flexibility. Yeah, that's better.
So that's a huge advantage, by the way, of using transform keyframes. You can just remove everything and redo it really quickly. Once you have it in frame by frame, it's not as easy to do because you don't change one asset over time. You change multiple assets over time. So that's why this way to create like this primitive rig to animate is a lot more efficient in this case.
Yeah, and also rigging doesn't have to be as complicated as it is in, say, Maya and things like that. You could just have a simple rig, and then you can work around it, and it doesn't have to melt your brain.
Exactly.
No bones, no weight painting.
It's nice because in the previous streams that you did, Dan, you did frame by frame, and then now you're showing us transform keys, and now they're both being used together nicely.
Yeah, the only problem is you have different frame rates, which is I'm not a fan of. But with the new feature, we are able to bake everything that I did here with the transform keys on the arm. I'm able to bake it, so I can maybe actually that would be a good thing to show, because I can maybe do a little bit more of the drag. So let me just bake.
So just to elaborate on what you just said, different frame rates is because transform keyframes interpolate at the frame rate that your headset provides. So if you have the Rift, the classic Rift, then the frame rate interpolates between keyframes at 90 frames per second. On the Quest is 72, and I think it's also 72 on the Rift S. So that way, if you do frame by frame and your master frame rate is 24 frames per second, basically the frame by frame runs at 24 frames per second versus like the arms run super smooth. So what Daniel's gonna do now is he's gonna bake the animation down so the arms will also move at 24 frames per second.
Okay, so in order to do that, I need to grab this guy here that contains the whole arm, right? I need to make sure I'm in the finish part of the loop point, and make sure this is a sequence, this folder, and make it loop, right? So now the arm is looping, and I click on that button right there, and it should make a copy of what I just did. But then hang on a second. If I do the same for the body also should be a cycle. I don't know what's gonna happen with this. Okay, that's good. So I baked the whole thing that was inside of this folder. So now I hide it so to show you guys that it's exactly the same, only it's frame by frame. So each one of those is a geometry, and it's all in one layer baked. So what does this allow me to do is use the trusty grab tool, which is my favorite thing in the world, and use that to further those dragging principles. So in this case, I'm going to use that nice ghosting, so I can kind of do this kind of stuff, right? Just bend those fingers a little bit more and give that flexibility.
And you're giving it more your personality too, which is great.
Exactly. So it doesn't feel so rigid. I can kind of bend the elbow a little bit. And we can have those fingers curling, and they unfold slowly, you know. But it's just so much nicer to do that because you establish the main motion with the transform keys. And the fingers are also joints that follow the same principles. You know, you have to imagine there's one joint here, there's another elbow here, another elbow here, another elbow here. So it's gonna follow the same breaking of the joints principle, right? So it's gonna break the joint, but later, after the wrist is changing direction, right? And I'm always trying to get those fingers to be on the previous, pointing at the previous place where they were in the space, right? So here's a good example. The fingers used to be here in the frame before. So in the current frame, I'm going to drag those fingers, and we're going to do a breaking of the joints in every finger, basically, to get that a reversal. Well, I call this a reversal when you have um, there's a moment in time where a frame is like this. I mean, a chain of joints is like this, and then the next frame, the chain of joints reverses into a different arc, right? So that's what's happening here. We're doing a reversal of the arc there because we kind of it's also the same effect as when you animate a whip, like a whoosh. So at the very end of that whip, the tip reverses from one arc to another arc, right?
That was a super impressive whip sound, by the way.
Thank you.
But you're not meant to add an in between that. Like it's supposed to be immediate opposite.
It's supposed to be a reversal that happens in one frame. From here, we have this arc. We have the opposite arc right there. So we are kind of dragging the fingers, and the amount of drag, again, is gonna be depending on the material of those things that you're animating, right? In the case of fingers, I know they can bend like that a little bit, but I'm not gonna go crazy like that. And I'm always trying to point and orient those fingers towards the previous pose, right? I don't know if that makes any sense. But yeah, this technique of baking is really, really helpful for that. So you get a much smoother drag in those fingers there.
Nice.
And you can feel the whip over there.
A little bit of like a smear, like a little.
At the, so basically a whip is the same principle. Here it will be the hand grabbing the whip, and this will be the first part of the joint chain. And a whip, the difference is, I'm gonna make a new 2D animation.
Just for your reference, you're 36 minutes in.
Oh, great. Yeah, just gonna explain. Yeah, this. Imagine we have Indiana Jones here, right? Indiana Jones is doing a motion down with his arm. I mean, this is the arm, right? Sorry, this is Indiana Jones. All right, so this is the same principle. Only we have a lot of joints. Imagine that we have, imagine this is a joint, flexible part, a lot of joints, and together they become a curve, this smooth curve, right? So Indiana Jones goes down with his arm. So the father joint is here, and all the children are following, and they're being dragged by the father, right? And then when you draw, you have to bear in mind this doesn't apply to CG animation. It applies to 2D animation or hand-drawn animation in Quill. You have to bear in mind the length of that whip, right? So if I move the base of the whip here and it's here now, the tip of it is gonna also change, and you have to bear that in mind when you draw. So if we continue with that whip action, and Indiana Jones is doing that, the father is here, the first joint of the chain is there, and it's gonna follow that. All the other children are gonna follow, right? And what happens when Indiana Jones changes direction quickly on that whip, right? So we're gonna make that arm going up really fast. So the whip is gonna break the joints successfully in all the joints, even but the children joints are gonna try as much as possible to be where they were before. So I normally draw this as starting from the children, from the tip, when I do 2D animation.
Because essentially you have to stay in model.
And let's say Indiana finishes the movement and it stops. So this is the end of the movement of the hand, of the father, of everything. So we're gonna, because the father stops doesn't mean the children stop. The children continue with the movement. And sometimes this is easier to do with a grab tool, especially when you have small little movements. Okay. And
Super awesome breakdown.
Normally from here to here will be less in betweens actually. So we have a little faster. Between this and this should be faster. And I'm just gonna get rid of that. Okay, so that's the same principle that I did on the arm, with only 1, 2, 3 joints, and in a whip action you have like 100,000 joints. I think that's it. That's all I wanted to. Instead of a whip, we can also have an animation where there is a. Let's do something else here. Okay, what I want to do is, let's say we have a character that has a ponytail. Just gonna do this in a separate thing. Head.
You can add it to the walk cycle.
That's a good point, but let me do it separately because I want to go a little bit more stream. I want to do something with more emotion to it, so you can really see clearly. So this is gonna be the tail. And in Quill, you could do this by animating the head with transform keys. So what I want to do is this body is gonna jump up and down. Let's do another keyframe here. To come down, up, and then it falls down on the floor again. And then once it's in the floor, I'm gonna make it jump to the side. It goes there, and it maybe hold there, and then dunk and bunk. Let's just get that a little bit slower. Faster. Well, yeah, doesn't matter. So in Quill, you could do this. You can animate the main body with transform keys, and inside of that group, you have the geometry of the head. Let's say this is a head. Imagine it has some eyes. Beautiful eyes. Beautiful face. Okay, and then you have another layer that's called tail, and you have that tail of that character there. And because it's inside of that same group, that tail is going to follow all the main movements of the head, right? So that's really useful to have that, because you have now the principal father movement, which is the head, and the tail, we can animate that separately in frame by frame. Or we can start the dragging just by doing the transform keys with rotation. So we can do that first. Let's make sure that the pivot is there. So gravity is going to be another force that's going to affect all of this stuff, right? So in order to take that in account, when the head jumps in up, the gravity is going to also pull the tail down, and also is a drag. So the tail wants to be in the previous position that it was before. So now the head is up and is racing and is reaching the apex of that jump movement. And eventually the head is going to change directions to go down. And that's a good moment to put the next keyframe. Opposite direction, right? Boink. But here it should be a little delayed, actually. Let me do another keyframe there. So that way it's a little faster when it changes direction. Okay. So now it changes direction and it reaches the ground, and the ground provokes the head to stop suddenly. So we're gonna do another keyframe here to hold that pose, and 2 frames later I'm gonna do another keyframe, really snapping that and changing the arc really fast. Papa. So now the head is moving not only up, it's also moving in toward the direction, the right. So just to quickly animate that, just gonna animate the rotation of that tail, pointing at where it used to be before. Right? And the same here, is reaching the apex of the jump. Animate a little bit, not too much change. And then when it changes direction going down, we're gonna really snap it. And same here, I'm just gonna snap it when it comes back up. Okay, that's really bad animation. but the principles are there. So now, because we animated this in transform keys, I wanna bake this out. I don't know if it's possible. Is it possible to bake if it's not a cycle?
You have to always put it into a sequence. You can put the tail into a sequence. Like you can create a sequence now, put the tail in there, loop it, right? So you can just put that in, go to the last keyframe, which you already, and set the sequence to loop.
So it has to be a loop, no matter what.
Yeah, yeah, because otherwise, Quill doesn't know how long it should bake because the timeline is infinite, right? So you could have a keyframe at like a 2-minute mark or something, and then you end up like baking for 2 minutes, or you would end up baking for infinity.
Oh,
you don't
I
want
get
that.
it.
So you always have to like tell the tool where it's going to stop baking, and that's by creating a sequence loop.
That makes a lot of sense. Thank you, man. So, okay, once I have this baked, maybe I can just go here and delete this whole group. I don't need it. And we have a tail that already rotates and moves in a nice way, kind of dragging. But we could, because we have frame by frame animation now, we're gonna go into more detail, and we're gonna make this really nice and make it look like an actual tail. So using the grab tool, and this is a bug that I would like to Quill to do. Quill doesn't calculate the onion skinning based on wall space. It calculates the onion skinning based on the transform key motion, which is kind of a problem because I want to see the onion skinning of this tail, and here I know it used to be here, but it's making me it's showing me the onion skinning here based on the father, and that's something that I don't know if it's possible to fix it, but I would love
Wait,
to.
isn't that what you would expect?
No,
This is
because
kind of like,
because I want this to be on the ground.
yeah, but if the main thing moves, isn't that inevitable? I'm just thinking out loud because if the main parent moves, then it has to move with it, right? No.
But I would like the onion skinning to be Walt related, not parent related. So.
But let's say like the ball jumps to the right now, right? Like super far to the right. Then you would see the tail by itself in place, the onion skin. You know what I mean? Like if it doesn't move with the parent, isn't that like super confusing?
Let me draw what I mean.
I think I understand what you mean.
So the tail in frame number 1 is here.
Yeah.
And the onion skinning of the tail, I know that's a wrong example because I drew something.
Okay. In the group.
I had to draw it on the root.
Yeah.
Okay, so so the tail here is in the floor. I'm just gonna name it because I don't even know what I'm doing. Okay, tail. That's the tail. Okay. So okay, in frame number 1, the tail is here. In frame number 2, I would like to see the onion skinning there, where it was in the. But because the onion skinning responds to is kind of attached to the parent as well. Anyway, it doesn't matter.
I'm super confused. I think.
So here, that's where the tail should be.
Right, like in terms of.
Yeah, I mean it's following the actual geometry is following the head, and that's nice.
Because if you turn on ghosting in Maya, I think exactly that's what happened too, right? Because the parent is moving, the position of the onion skinning will match the next position of the parent.
No, in Maya you see this, like you have this character, and it's in wall space. That's his position. So now the onion skinning should be this exactly. It should be the first frame. So this is.
I think I.
So this is frame number 1, but it's only frame number 1 of this layer. But what I want is to see the frame number 1 on the wall when I do onion skinning. When I see the onion skinning, this red ghost here should be exactly that I drew here, because that's what I envisioned the first frame, which is here. Yeah, it's
like the root of the onion skin also moves,
exactly,
rather than it just showing what was in the last frame.
Exactly, that's much better explained than I was. So anyway, drawing, this is going to help you as well. Having a layer on the root to draw your onion skinning yourself sometimes is going to help you to avoid that problem, right? So let's keep doing that, and it's great that I have this reference here because I know the children, like I said, always wants to be where it used to be before, and also being careful of the length of that tail. So if I'm dragging that, the tip of the tail is going to move, obviously.
I'm so slow now. It clicked. I know what you mean now. I'm like processing quietly. And then I just understood what you meant.
So see now that the onion skinning here is not helping.
Yeah. Because it's not doing a global onion skin on the whole
Exactly.
thing, right? Yeah. Okay. That's funny. That's like I was super confused.
Okay, so now the I'm following and doing using the grab tool to distort the chain of a tail.
Your video is a little bit choppy right now. I don't know.
Oh,
if
it is.
I think he's just. Is it choppy?
And I'm just flipping back and forth.
Yeah, I think it's him working.
And doing this back and forth.
No, it is actually choppy.
I don't see any movement.
Oh, that's
it's
weird.
a little.
Yeah.
Now it froze.
Yeah.
Oh, okay. Well, then that's a problem. Let me.
Completely.
maybe do a reboot. Possibly?
Yeah. Let me stop streaming. And how are we doing in time?
Oh, we got 5 minutes.
Oh, great, because that's the end of it. Do you still see it? Okay.
Good now.
It's better. Yeah.
It's better now. Okay.
Yeah, you're back.
Okay. Let me just finish this little part here, and you can see the workflow, right? I'm trying to get the tip of the tail and try to drag it so it points to where it used to be before, and eventually, all this joint is kind of breaking and bending. And if you follow that simple rule, you're gonna get some nice results. So the tip of it, the tip tends to have a you're gonna notice the tip of the tail will have some sort of a nice arc. So it's always good to remember that too. So if you follow that arc, you'll get a nicer, smooth animation there. And here, instead of moving a lot of joints, it's really nice because I'm just using the grab tool. So the children are catching up with the action, right? They're late. So I have to imagine all these joints inside of that tail, and each one is rotating and it's kind of catching up with whatever the parent joint is doing. And because it's all baked, we always start from a clean model of that tail, which sometimes is good, but sometimes it's a bit of a pain because you want to keep that similar. But that's fine. We have 5 minutes. I can just finish that quickly. Maybe turn on this for now because we're pretty still right now. And we're gonna, in a minute, we're gonna have that whip action that we did before, because we're gonna have a sudden change of direction, so it's gonna cause everything to snap. So now we're getting into boom, quick snap there. Can make it a little bit more exaggerate. And then boom, we're switching and we're flipping that curve to the other direction. And now we have a very quick change of direction on the head, so I'm using the wrong reference. Just trying to get that wall space onion skinning. But what I do instead of onion skin, I just flip back and forth and try to compare and try to see if I'm dragging this correctly. And here, there's a nice phenomenon here that happens is, see how the tip of the tail is the last one to bend over to the other direction, because we have that really fast change of direction there from the patterned joints. And sometimes this is better to just do it roughly with just drawings instead of grab tooling, like I'm doing right now. And then use the grab tool to just to do the final version, the nice polished version. That's what I do. That's what I did on the Remedy when you see the ponytail flowing with the wind. I did that first in a very rough way with just drawing quickly like a traditional animation, and then I used the grab tool with the proper model that had all the shadows and all the colors and all that, and using grab tool based on that drawing that I had rough before. But I'm just going really quickly right now. I'm out of time, so let's just see that.
Nice.
It's almost like a squirrel.
Nice.
That's awesome.
All right, so that's kind of what I wanted to talk about today, and I'm happy that the timing was good. Yeah, exactly 1 hour. I didn't go too crazy this time.
Can you show the walk cycle again? Do you still have it?
Oh yeah. I hidden all of that stuff. Let's just hide all of this. Let's hide all of that stuff. And the arms. Well, I did only one arm.
Yeah, you can quickly just duplicate it and offset it, right?
Yeah, once you have an arm swinging in a proper way, you can just duplicate it, put it in the other side, mirror it, and offset it so it's swinging the opposite direction. And the swing of the arm, is always the opposite of the leg. So when the leg is forward, the arm goes backwards, and when the leg goes back, the arm goes forward. And that's because of the twisting of the chest and all of that. And then maybe on the next class, I can talk about, we can add all the stuff together. We can add the head, and then we can have a ponytail on the head. So we can or maybe we can just finish this whole part here, and maybe I can talk about something else on the next class. I have to think about it.
Yeah, I think you were talking about like how to do like those optimized but super clean like shapes, like what you did in the vampire piece. I think that would be like a cool thing, because I think this was like super educational for follow-through action. I mean, even if you do the head and stuff, I think the principle is the same.
Yeah.
So I think if you just follow this class, I think you should be able to understand how to do the rest.
Yeah.
So
yeah.
I think it's kind of like a good closure class.
Yeah, I think I'm gonna finish the series of walk cycle with this one, because everything else, if I do the head and everything, is gonna kind of repeating the same concepts. So, any questions that you guys are
of how you made some of the characters and sets and stuff in the Remedy? Maybe that could be another one.
Oh, that's a suggestion for another class?
Yeah.
Yeah, Goro was talking about it. Maybe next class that I'm gonna do, I want to talk about how to create a face of a character.
Yes, please.
With nice, smooth shapes on the face. and kind of
Because everyone's process is different, so it's
yeah. I want
to.
to show you my process too, especially when I did the vampire. Some people were asking me, how do you get that face so smooth? And so I wanna talk about that because I think it's a cool process, and it's a good way to optimize as well, because I use mainly this guy here and just straight lines like that. Um, like really, I use this a lot. I use this guy, and I use the thickness and the grab tool to just use that as if I'm using clay, and these are my pieces of clay, and I put them on the face and whatever. So I can talk about all of that, and I think it could be really interesting.
Yeah.
If you guys like.
That was.
Yeah.
Will you cover animation of the face or only the modeling?
Only the modeling. I think that will take
Okay.
I think that the whole thing that can take an hour, because I wanna also show how I start from scratch.
That would be great.
I wanna get like a reference image, maybe a photo of or a drawing that I've done, and start from the very scratch and start drawing the face and how do I approach that stuff, right? I want to show you all that stuff, and then
You had it in that presentation, and it was nice, but it'd be cool to have it as like a little class.
Say it again.
Because you had it in the presentation that you had for the remedy.
Yeah.
Last week, so.
Yeah, just that, but slower and step by step.
Yeah, it was a nice teaser.
Totally, yeah. All right. So if you're
super
okay,
cool.
I'm gonna stop recording. Thank you for watching the class, and we can hang out after recording and talk a little bit more if you like.
Thank you.